So let us power up this induction stove, and I'm going to use this pot which is specially made for induction stoves. It has got a special base. Look at that. Magnet sticks to it. This is a ferromagnetic material. And watch what happens when I place this pot on top of the induction stove and put on. You heard that beep, and you heard the fan whirring inside. There's a fan inside. We're going to have a look at that. I'm going to open this shortly, and look at this. This is the temperature. It's going to reach 1000 degrees centigrade. There's nothing inside, so I won't continue heating, and I'll put this off. And now let us try this aluminum pot, aluminum pressure cooker. Its base is also pure aluminum, non-magnetic. Magnet doesn't stick to it. Let us watch what happens when I place this on top of the and put it on. Look at that. It keeps on beeping and shows me error here in the display. It's not detecting this pot. The base of this is copper. And let me put it on. Same thing happens here. Error. It's not detecting this copper-based pot. Let me try steel, the regular steel, and look at that. Detected this steel. This stainless steel and non-magnetic. And still it detected, let me put this off, and still it detected this stainless steel pot, because stainless steel contains a lot of iron. Stainless steel is alloy of iron, a ferromagnetic material. So this stove is designed to detect ferromagnetic material. So it won't detect aluminum, it won't detect copper. So basically, eddy currents are generated in this ferromagnetic base of this pot, and the resistance of iron or ferromagnetic material is very high, resistance to electric current, and those eddy currents end up generating a lot of heat in this base. Also, this being iron, it gets magnetized and demagnetized, magnetized and demagnetized, producing hysteresis loss and even more heat. So heat generated in ferromagnetic base is very high. The frequency of the magnetic field here generated by the coil inside, which we are going to have a look very soon, is 25,000 hertz, 25 kilohertz. It's a good conductor of electricity. It can produce eddy currents when placed in external magnetic field or changing magnetic field, but the stove is not detecting it. What happens with aluminum is, aluminum has got very low resistance for the electric current, and eddy currents won't produce any heat. And this being non-magnetic, there is no hysteresis loss, or magnetization, demagnetization doesn't happen. Same thing with copper. Copper has got very low electric resistance, so eddy currents won't generate any heat. And even copper being a non-ferromagnetic, the hysteresis loss is absent. This stove is designed, the internal circuitry and everything, to sense high resistance to the eddy currents. And that can be offered only by ferromagnetic material. And that's the reason induction pots have ferromagnetic base or iron base. There are induction stoves which are specially designed for aluminum and copper, but the operating frequencies are very high, near to 100,000 hertz or 100 kilohertz. Let's open this induction stove. Let us have a closer look at what is inside the induction stove. These are the internals of the induction stove. What you see here, the main part of this induction stove is the coil. And this coil is driven by circuitry underneath. See that electronic circuit there? It's a switcher. Switcher means it produces very high frequency electric current, 25 kilohertz. And you see this is a heat sink to cool down the components underneath. Electric current always produces heat. Higher the current, faster changing current, higher is the heat produced. So a lot of heat is produced by the circuit itself, but this is not the heat that heats up the pot. This is the heat generated by the operation. That 25 kilohertz of current passes through this coil, and this coil generates 25 kilohertz varying magnetic field, which penetrates through the ceramic glass top of the stove and generates eddy currents in the bases of the pot. That's the working of the induction stove. This is the control panel, all the switches that you see on top. The circuit is for that, maintaining the temperature, the modes, various modes, and so on. And there's a fan here. This fan will drive out all the hot air from inside out. There's a heat generated by the operation of the circuit and also the heat penetrating from the top of the base. And that heat comes from the hot base of the pot. So this stove does not involve generating heat and then transferring it to the pot. It actually generates the heat in the pot. The magnetic field from here is involved in electromagnetic induction that induces eddy currents in the base of the metal pot.